This video is on developmental networks dealing with the show Sex and the City. A developmental network is something that provides links and shows relationships between certain genes. The links between the different genes can either be activating or repressing in relationship. Activating relationships allow you to move on to the next stage of the developmental network, whereas repressing relationships blocks you from going to the next stage. Activating relationships are represented with arrows, and repressing relationships are represented with T-bars. So now I will show you an example of a developmental network dealing with the show Sex and the City. Each week, Carrie has to write a column for The New Yorker about dating. This week's article was about Carrie's love life and in particular her crush on Big. Samantha is in huge support of Carrie's love for Big, so she would stimulate the transcription of this article on Carrie's love life. Miranda, however, doesn't want to hear about this love for Big and is trying to block Samantha's support of Carrie, so she would inhibit the transcription of Samantha's support. Charlotte, however, seems to see both sides and just wants to stay out of it. She tries to stop Miranda from voicing her negative feelings towards Carrie's love life, so she would inhibit the transcription of Miranda's negativity and concerns for Big. Taking a look at our developmental network, we can see both Charlotte and Miranda are repressors and Samantha has an activating relationship toward Carrie's column. The way we figure out if Carrie writes her article on Big is looking at each step of our developmental network. We start at Charlotte and see that she is a repressor, so she will block Miranda's decision out. Since Miranda is being blocked or repressed by Charlotte, we then look at Samantha. Samantha is an activator, and she will push for Carrie to write her article on Big. Since Samantha is last in our network, Carrie's article on Big will get published. Taking a deeper look. Two proteins, A and B, help regulate the translation of these genes to the production of Carrie's article. Our protein A represses the transcription factor in Charlotte's mRNA. The protein A is near the 3' end. This eventually leads to the repression of Miranda's mRNA and will eventually give us Carrie's article as a result. This is very similar to our fruit flies example, where our bicoid protein represses the caudal mRNA translations by binding to the caudal mRNA near the 3' end. Now we will look at an example of a single mutant. If Miranda is removed from our developmental network, we can go ahead and cross her out. Looking at the first person, which is Charlotte, we see she represses Samantha. So Samantha's opinion on Carrie's article is now blocked. If Samantha's opinion is blocked, that means Carrie won't publish her article on Big. We can also see double mutants in our developmental networks. If both Charlotte and Samantha are removed, we will see Miranda will block or repress Carrie's article on Big. This means she won't publish the article. And these are my references.